Hey guys, how is everyone doing? We're going to continue our look at congruent triangles by showing how we can, I'll go on the next slide, use congruent triangles to show that different parts of those congruent triangles are congruent, and not the ones that we actually use to solve to show that something's congruent. So how are we going to do that? We're going to use this theorem. I kind of jokingly call it this theorem because it's Cpctc. And Cpctc is basically congruent parts of congruent parts of congruent triangles are congruent. So that's where we get the Cpctc from. And like I said, I call it this theorem just because it's kind of a whole bunch of things get together. But basically, that means if we know that two triangles are congruent, we can prove any corresponding parts are congruent. Which kind of makes sense because if they're congruent, they're by definition, their corresponding parts have to be congruent. So basically, we want to prove that Q is congruent to T. So we want to prove that Q is congruent to T, and how are we going to do that? Well, how we're going to do that is we're going to show that triangle QPR is congruent to triangle TPS. And we're going to do that by, we can say that those angles right there are congruent because the vertical angles are congruent. And then we can say that the triangles are congruent by side angle side. Okay. And once we've done that, then we're okay to say that Q is congruent to T. Okay, so just one way that we can use those triangles to prove that they're congruent. All right. Next, we've got some overlapping triangles, so sometimes that can be a little difficult. But what we want to prove is we want to prove that GK right here is congruent to HJ, which is right here. And again, sometimes that helps. So what triangles can we use to prove that those are congruent? Well, we're just going to need this big triangle right here and this triangle right here, or that triangle there, and this triangle here to prove that they're congruent. All right, and there's a whole bunch of stuff with angle addition that we can use to prove that those are true, but the triangles that we're going to need to prove true are going to be triangle JHN, and we're going to have to prove that that is congruent to KGL in order for that to work. And later, probably in the next section, we'll actually do the proof for that. All right. So how can I prove angle 1 is congruent to angle 2? On the notes that you guys have, I said redraw the triangles if we want to prove 1 is congruent to 2. But which triangles would we want to redraw? We would want to take this triangle right here. Okay. And we would want this triangle right here. Okay. So I'm going to redraw them so that I've got angle, or I'm not going to redraw them, so that I've got angle FIE. I'm going to draw the right angle in there. And I'm going to draw the right angle in here. But those aren't actually 1 and 2 now that I'm looking at that. FIH. Okay, so we've got those, but what we really want to prove are these angles right in here. Right. So how can we do that? Well, we can prove that those bigger triangles are congruent because they have Fi, and we have this, 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 and this. So those larger triangles are congruent by side, angle, side. So I've got the big triangles that are congruent by side, angle, side. So that means that these are going to be congruent here and here. Okay, so it's going to mean that we've got, actually what we can do, I just totally screwed this up, which is fine, because remember I told you it's kind of like a rough draft. We can actually say that these two angles are congruent here, and then I've got FE congruent to IH here and here. So I can actually prove that FEG is congruent to, didn't draw a very good triangle there, IHG, because I have this congruent to this congruent here, and then we've got vertical angles are congruent, and these are congruent. So we can say that those triangles are congruent by angle, angle, side, and then angle 1 would be congruent to angle 2. Now what I want you guys to notice, and the reason that I didn't erase this and I didn't start over, is because I wanted this proof one way and it wasn't working. Okay, I want you to see that even I do that. I've taught this lesson several times over several years, but right away I jumped in and did the wrong thing. And that's okay. That's how these things work. Proofs sometimes aren't going to jump out at you right at first. And I know that's some of your frustration, but I want you to see that those are things that can happen. All right, let's go ahead, and you know me, I like 2-column proofs, and we want to prove we're given that GK bisects angles FGH and FHK. So this angle here and this angle here. And we're going to prove, or we want to prove, that FK is congruent to HK. So logically, let's start with our statements. We have our reasons. Okay. Statements and reasons. The first thing I'm going to state is that GK bisects angles FGH and angle FKH. Okay, and we know that's given. So our logical step from there should be saying that whatever it bisects, we have congruent angles. So we can say that that's congruent. And I'm actually going to name these 1, 2, 3, and 4, because it's going to make it easier for our proof. So now what I'm going to say is, keep going backwards, that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 by the definition of a bisector. Okay. 3, I'm going to state that KG is congruent to KG, and that's by reflexive. Again, the only property my niece seems to know, but I love her anyways. Okay, and now I can state that those triangles are congruent by, so triangle KFG is congruent to triangle KHG by side, angle, side. And now that those are congruent, I can use the Cpctc to say that FK is congruent to HK by Cpctc, which says that congruent parts of congruent triangles are congruent. Okay, so we proved the triangles were congruent first, and then we were able to say that the sides were congruent. All right, so you have the next proof, and I would like you to go ahead and prove that by yourself, and then we will go over it. Actually, take a minute to prove it. I'm going to erase all this because I forgot to put that slide in there. And I'm so close to being done, so we're going to erase this, maybe. Or actually, maybe what I'll do is I'm going to stop real quick. I'm going to keep that, and I'm going to add a new slide. So you guys can see how I do this, right? All right. And so we have got to prove, we've got a given that JK is parallel to QP, and JK is congruent to QP. And we want to prove that KQ bisects JP. And let me draw the diagram here. So we've got KJ, PQ, and M. And I'm going to, based on what I know, I'm going to mark the diagram by the things I know. So I know that JK is parallel to QP. I know that KJ is congruent to KP. And I want to prove that KQ, so this line right here, okay, bisects JP. So we're going to need to prove that JM is congruent to PM. So we're going to prove that the triangles are congruent to do that. All right. So with our statements, I'm just going to name the first given. I'm just going to use that because it makes logical sense that JK is parallel to QP. And that is given. And since those are parallel, I can say that this angle and this angle are congruent, and I can also say that this angle and this angle are congruent. Okay, because I've got those two transversals. So I'm going to say that angle K is congruent to angle Q, and angle J is congruent to angle P, and that is by the alternate interior angle theorem. All right, so my next step then is going to use the JK is congruent to QP. And now I've got enough, and that was given, to say that the triangles are congruent by side or angle side angle. So KMJ is congruent to triangle Q, and I'm paying attention to what order I do it, MP, and that is by side, I keep doing that, angle, side, angle. Now that I've done that, we've got to know that KQ bisects JP, so that means that we need those things to be congruent, and these are congruent. So JM is congruent to PM by Cpctc. And then we can state that KQ bisects JP by definition of a segment bisector. All right, so we've used Cpctc to prove a couple different things today. So hopefully you can see that we can actually prove that things are congruent once we've proven that triangles are congruent. Have a great evening.